Hello guys, welcome to Pepcoding, and today we're gonna solve this question, gold mine 2. So we're gonna solve it in Java. So first of all, the flow of this video will be something like I will gonna explain you the question statement first. Then I'll explain you what is the approach of this question. Then I will explain you. Then I will do a dry run for you, and at last we will just code this question. Okay, so in all the iteration, you're gonna understand something. So please don't skip the video first. Second, keep your concentration here for some time, and you will gonna understand from this question you will understand a lot of concept of recursion and backtracking. The third thing is, if you have already done flood fill, then this question will make your recursive recursive thinking much better. If you haven't done the flood fill, then even then it's okay, you will understand this question. But now let's just jump into the question and we will solve it. So first of all, let's understand what the question is saying, what the question is asking from us. For that, let's take an example first. So we have given a 2D matrix. All right, guys. So we have given okay. We have given a 2D matrix, and what we have to do is we have to travel through that matrix, and we have to find what we have to find. We have to find the maximum gold or the maximum value we can get from traveling through that matrix with some constraint. So what is the constraint? That is the main thing. So first thing is if there is a 0, you cannot visit. So if, for example, I have to start from this path. I have to start from 1, and I will start travel to 4. Then the sum is 5. Then to 2, then the sum is 7. Then to 8, then the sum is 15. Then to 2, then the sum is 18. But think about it, like this number is 0. Okay. So from 18 we will jump to this. So it is like what? 18 plus 4 is 22. Right? But now there is ball and there is ball. So I cannot move any further. From this point I cannot move any further, right? So the sum of path till this point of this path is 22. Or let me be much clear. If this is 0, then there is this path with a sum of what? 22. So if there is a 0, you cannot visit. You cannot visit and you cannot cross. Okay. First thing. Second thing is start and stop at any point. So I can start my traveling from any point. Like I can start from here, from here, and I can end at here. Like I can start traveling in somewhat this way. I can start traveling in this way. Or any way is possible, right? I can start traveling from any way is possible, but I have to find what? I have to find maximum gold from any path. This is the basic question. We have to find the maximum gold from any path, but if there is a 0, you cannot visit and cross that area. Second, you can start and stop from any point. All right. Now let's understand its approach first, and then we will just jump on its code because it's a pretty much easy question. So first of all, let's take a smaller example for our dry run, because this is a very big example. Let's take a smaller example. Let's make a partition also, because I also need some more things for this question. First of all, let's think we have given this matrix like 0, 6, 0, then 8, then 9, then 7, then 0, then 0, and then 5. We have given this kind of matrix. Okay. So what I think gonna be approach is, I will make DFS calls from every point. I will make DFS calls from every point. Like I will make from here, 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 from here. So I'll make DFS calls from everywhere, and I will get the maximum of the all the path possible from that point. For example, if I start from this point, so how many paths are available? So one is this, right? Second is this, right? Third is also this one, right? So from this point, there are three paths. So what I will get, I will find the maximum of all the paths available at that point from DFS, right? This is the first thing. The second thing is, then I will get the value from every point. So at last I will get the maximum from every path, and that I will return maximum from every point. Like I got the maximum from, if I start from every point, I get the maximum, right? Such way, in the end I will get the maximum of every point. All right, so now let's start doing this question. But there's one more thing. Like if I am here and I make a recursive call to this point, or DFS call to this point, and this point make a recursive call to this point, then at this point I will start jumbling in the cycle. That will never stop. So to stop from this point, I take a visited array, from which I will know that these are the positions I have traveled. So let's create a visited array. There we have, this is also done. Make this, and last you have to make this. Okay, then there's this one block, there's this one block, there's this block, and then there's this block. All right, and at the start only false is present. In this matrix only false are present. False means nothing is visited till now at the very start. But now we will start our DFS calls. First of all, I make a DFS call from this point. So if I make my DFS call from this point, can I make it? No. Why? Because there is already a boundary. There is a wall. So at wall, I cannot make anything. Now we point to this point. So first of all, my first thing is to make this true. Let's make it true. After making it true, let's make our call. So first call is from this side. We make a call, but there's what? There's boundary. So from boundary, I cannot move. I cannot visit 0. Right? So the only possible way right now I'm seeing here is this call from 6 to 8. So when I make a call to 6 to 8, I have to make this 8 also true. Right? From 8, I make a call to this 5. Now when I make a call to 5, I have to make this also true. These three are done. Now understand one of the most critical part of this question. Now we are at one of the critical part of this question. Let's make it a little above. Okay. Now we are here. Now 5 has to make a call. Right. Now 5 has to make a call. But the thing is, 5 cannot make a call to this side. Why? Because there is already a boundary. Then 5 also cannot make a call to this point. Why? Because there is also a boundary. 5 cannot make a call to this point. Why? Because this is out of bound. So now comes the more interesting part is, this is what? This is we make them true before making the call. Now we have to make them false after making the call. So now when we go from our recursive call, so in the backtracking part, we have to make them again false, because there are multiple ways we have to travel, right? So for that we have to make them false. But one more thing, what it will return from this point? The thing is, it is getting 0 from here. It is getting what? 0 from here. It is getting 0 from here, and it is getting 0 from here. But what will it return? It will return maximum of all calls maximum of all calls plus self means, let's understand. It will return maximum of how many calls are here. There is a call for up, there is a call for down, there is a call for left. So whatever the maximum I will get from all these calls plus self. Self is what? 5. So what I will return from here is, from here it will return 5. And before returning, we have to make it again what? False. Then we are at this point 8, right? At this point we again have to make them backward. Again, sorry, not backward. Sorry. Now we have to make a, again we have to make a call, and this time we will make a call to 7. So before making the call, we again have to do what? We have to again make it true. Again make it true. Now 7 has to decide. First is this call, second is this call, there is this call. It will return what? 0 from here, 0 from here, and 0 from here. So what it will return? Up, down, and left. Sorry, up, down, and right. Right plus self. So self is 7. Then self is 7. It will return what? It will return 7. This call is done. Now let's talk about third call. Third call is, let's remove it first. Right. We have to make a call to this side, but in the backtracking part there is one more thing we have to do. We have to make it false again. We again have to make it false. Now in this part we again backtrack to 9. From 9 we have to try this point, we try this point, we try this point, but we will return 0 from here, we will return 0 from here, 0 from here. From here what I will return is 9. Why 9? Because 0, 0, 0, maximum of 0 is 0 plus self is 9, so I will return 9. Now we are again at this point, but one more thing, we have to make it, one more thing, I forget that we have to make this also true when we have to make this true when we reaches to 9, and in the factoring part we have to make this also false. Right, this is done. Now we are at this point. Now at this point we again have to backtrack because there is no calls left. So when we backtrack, what we will return? We will return maximum of 5, of 7, and 9. Maximum of all of these 3 is 9 plus self. Self is what? 9 plus 8, which is what? We have to return 17. So at this point we are getting 17, and this also we have to make it false. Two things are done. Now we are at 6. Now again we have to do the backtrack part. From here I will get what? 0. From here I will get what? 0. From here I will get what? 17. So what will I return? Maximum plus self, which is what? 17 plus 6, which is what? 23. So at this point I am getting the answer as 23. Alright. At this point the maximum of all the paths is 23. Right now this is 23. So by this means we have to follow this formula. That from here I will get 23, from here I will get something. I will not get something from here because there is 0 already. From here I will get something, 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 and from here I will get something. But the maximum of all of them will be my answer. Okay, remove it. Maybe you cannot see here. The maximum of all of them will be what? Maximum of all of them will be my answer. Are you getting my point? At B, when DFS, before making this recursive call, we have to make it true. After making the recursive call in the backtracking part, we have to make it false, and we have to get the maximum of every path. And at the end, what is the maximum from every path will be the answer. Simple. Now let's start to code this solution. We are at this point. Let's make it a full screen. So now what we need to do is, first of all, we need to travel through that matrix and we have to travel through every point of that matrix, and if there is no zero, we have to do what? We have to make a recursive call, right? If you remember. So we will gonna do that. So first of all, I'll say for int I is equal to 0, I is smaller than n, and I plus plus, and for int j is equals to 0, j is smaller than m, and j plus plus, right? What is n and m? So first of all, define this n and m. N and m. So int n is equal to grid dot length. Okay, and int m is equal to grid dot length. This is done. Here, now I have to do what? First of all, I have to make a boolean of visited. So let's create it, boolean of visited with the same size as our grid of visited is equal to new boolean n and m. One thing is done. Now I have to check if grid of I and j is not equals to 0. If that place is not equals to 0, at that time I have to do what? I have to make my recursive, or I will say DFS call. So what I have to do is max gold is equal to math dot max of max gold comma get maximum gold underscore. So I will make a new function for my recursive call, and whatever I get at every point, I will take a max gold variable. Let's create a max gold variable, int max gold, and I will save the maximum of them. So from this way, I will at every point I have the maximum till now, and I also have the maximum that particular point. Now let's send the argument. So first of all, I should send int grid, then I, then j, then n, then m, and at last I have to also send visited. This is done. Okay, and after this I have to do one more thing, which is return max gold. So this function is done, right? Now I have to do what? I have to make my DFS function, which is important, right? Now I have to make my DFS function. So public static int get maximum gold underscore, right? First of all, let's take the argument. So which was int grid comma int source comma int source column comma int n, int m, boolean visited. This is done. Now public static int get a maximum. So first of all, what I need to do is I have to make my visited true. This is the first thing. Second thing, I have to do what? Make my recursive calls. And at last I also have to do what? Visited false. And after that I have to do what? Get max and add self. So after that I have to return get max and add self. I have to find the maximum, and then by adding self I have to return it. These are the basic things. So let's start doing it. So first of all, I have to do what? Visited source row and source column is equal to true. Then the thing about recursive call. So first of all, I will make a left call get maximum gold underscore, and what I need to send is grid, then source row comma source column, let me change it, source column n m visited. This is done, right? But I have to make recursive calls for every point. I have to make recursive calls for every point which are available. So I have to also make call for right, I have to also make call for up. I also have to make call for what, down. So for the left, I have to do what? Subtract a column. For right, I have to do what? Plus a column. Now for up, I have to do what? Subtract a row. And for down, I have to do what? Increase the row. Increase row number, decrease row number, increase column number, decrease column number. Just right. Now after that, I have to do what? Visited false. Visited of source row, source column is equal to false. And in the last part, I need to do what? Return math dot max of left, comma, math dot max of right, comma, math dot max of up, comma, down, bracket, plus I have to add myself, right? So grid of source row and source column. So I got the max and I add myself. Now let's talk about base case. What should be the base cases? So if all the edge cases are base cases, so if source row is smaller than 0, or if source column is smaller than 0, or if source row is greater than equals to n, or if source row is greater than source column is greater than equals to m, or visited of source row and source column is equal to true. If it is already visited, or grid of source row and source column is equal to 0. I have to do what? I have to return 0. This is done. So now let's understand one more time the flow of the question. We get our grid. We make a traversal for every point, and for every point we do what? We make a DFS call, and also we try to find the maximum till that call from that maximum gold variable, right? And till max is the max at the last point. Max gold will be the maximum. Now in our DFS call, which is get maximum gold, we do what? We make the visited true before the recursive calls. We make the visited false after the recursive call because of backtracking part, because we can get a multiple path, right? That's why. And we have to return what? Maximum plus self. This is all. Now let's try to run this code. If there is any compilation error, we will sort it out, but there is everything fine. So let's try to submit this code. And okay, it is taking longer time. But one more thing, that if you haven't done the flood fill, after this video, please do your flood fill. Okay, so some of the test cases got failed. Let me check. So guys, some of the test cases got failed just because these test cases are not updated yet. But the solution is completely fine. So this solution is completely okay, right? So if you understand the concept, if you understand the logic of this question, please like the video. If you have any query left regarding this question, please comment it out and subscribe to our channel. Thank you so much, guys.